So I often have shots at other subjects, such as math being too simple, such as with the Nernst equation. If you have 1 molar of everything, you've got to log one, you get a zero, and the algorithm doesn't work. And the other best friend of chemistry, physics. I even have pot shots at physics because it relies on mathematical models, and so that's not going to be good enough. So just to be fair, in response to a colleague of mine, a physics colleague, I'm going to have a pot shot at chemistry. All right. So the problem with chemistry is the universe is a three-dimensional electrostatic attraction between pos and neg. And what we do is we put sort of a vague mask and filter over it, which is English, and even our eyes and what we can see. But we have to think how the universe thinks, which is not what the filter of what our eyes are telling our brain, and it's not the English language. It's just a three-dimensional variation in degrees of positive and negative. And if you think in that way, then you'll understand everything. And so that's why you got to, when you're in trouble and you've got to try and really understand how something goes, you've just got to ignore English, ignore what teachers are saying, ignore what your textbooks are saying, and just think how the universe thinks, and then it will all make sense. It's a lot like the Matrix, all right? You got to get down to the POSNEG code to really understand why the heck it's doing that, all right? So this really sort of was also catalyzed not by just my colleague saying that, at least I'm fair, I attack every subject, but I haven't attacked chemistry, so now I am. All right, so I'll be completely fair and attack even chemistry. There was a question about why you use KHP rather than NaOH as a standard. And basically the answer was sodium hydroxide absorbs water and it's hygroscopic. And I think there's about 8,000 students the year before. I think it was the year before, and only 2 of them got it correct, which is probably them memorizing sodium hydroxide is hygroscopic. But then I found out there's an alternate answer, and the alternate answer was KHP has a higher molar mass than sodium hydroxide, so it'll have a smaller error. And so if you do the percent error, so that's tared and then measured, so it's double the smallest increment and then times that by 100. It's 0.01 versus 0.05, which is going to get written off, rounded down to 0 when you take into account the numerous other errors that are going to occur. There's a relative difference of 5 times bigger. That's just misusing statistics and fooling people. So the error, the effect of the molar mass, 4 times molar mass, is 0. It's no effect whatsoever, and that was accepted as an alternate error. So I'm wondering whether 0 people got this correct. Whether of those 2 people that got it correct, did they allow that? And also, hygroscopic, did they just memorize that? So I feel like, okay, so maybe none of the students understand chemistry, all 8,000 of them. I know that's not true, but in that question, that was a complete fail. So what you have to do is you have to understand the pos and negs, all right? And that won't get you any marks on the test, but it'll mean that you understand chemistry much more than everyone else. So if you have H2O basically has positives and negatives there. And so what you have here is like a benzene ring, which is nonpolar, and that's not going to attract water. And then you have these charges here that are sort of in steric hindrance. So that's not a strong negative charge, and you've got these positives here as well. And so there's not a strong polarity in this area here. Plus this steric hindrance. So the water is not very easily attracted to that. Okay, so that is why. Now, pretty much everything will attract water to some degree, even hair or pine cones or salt. And let's just talk about salt. Salt is a crystal, and they're very compact and combined in a nice rigid structure. And so there's only the outside surface area that could be attracted to water. So it is certainly more hygroscopic than KHP, potassium hydrogen phthalate, but not as much as sodium hydroxide. So if you look at the 3D structure of sodium hydroxide, you've got these very large open spaces of negative and large open spaces of pos. And so that is a huge open space, so the water molecules from the air can get in there and bind in there. And that's why it is so highly hygroscopic. How hygroscopic? 50%. Okay, so what do you think that is compared to that? Okay, that will override every error in the experiment. And so the real reason, or the real understanding, should be why is sodium hydroxide hygroscopic, more hygroscopic than KHP, and you should be talking in terms of three-dimensional attraction of pos and neg. All right, so that's the proper way to understand chemistry, and that's what we're doing wrong in our textbooks, okay? Basically for everything. All right, you'll see me use that in explanations when necessary, when things get difficult in my videos. All right, so there you go. Got to lift our game, guys.